Now let me explain to you the definition of pole and polar of a parabola. Now we consider the equation of the parabola y square is equal to 4ax. Now first of all you draw a parabola, that is this one. Then after that take a point P having the coordinate x1, y1. This point P can be inside the parabola or it can be outside. So I'm considering the case of in this figure I'm taking P to be inside. You can check from the notes I have drawn the figure also when P is considered to be a point outside the parabola. Now through this point P you draw a chord QR. Now this is a chord QR, and draw a tangent at next you draw a tangent at Q, that is this one, and also a tangent at R, that is this one. Now let these two tangents at Q and R which passes through the point P meet at point T outside the parabola at point THK. Now if you draw a chord again which passes through the point P, say Q prime R prime, then again you draw a tangent at Q prime and a tangent at R prime. Then let these two tangents meet up at a point TH prime K prime. Now if you join this point you'll see that you'll get a straight line. So in this case if you draw any line through passing through the point P having the coordinate x and y1, you will get a chord. Now at the extremities of those two chords you draw tangents, and then those two tangents will meet outside the parabola, and you'll see that those two tangents will meet along this line. Then according to the definition of polar here is defined in this way. The path traces by the point of intersection of the tangents drawn at the point say Q and R, where QR is a chord which passes through the point Px1, will be nothing but it will be a straight line. So here you see that if the tangent at Q and R, where QR is a chord passing through Px1, y1, and their point of intersection is at this point, then you'll see that it will be at this position. If you draw another tangent at Q prime and R prime, which is where Q prime R prime is a chord passing through again through the point Px1, y1, then it will meet at this point. Then in this way you'll see that all those tangents drawn through the point of intersection of tangents drawn at the extremities of a chord passing through the point Px1, y1 will give you a straight line. So that means the path traces by the point of intersection of the tangents to the parabola at Q and R here will be called as the polar of the given point P. This will be the given point P, and this given point P is called as the pole. So given a point P which is known as the pole here, then through that pole here you can draw a chord QR and then draw the tangent at Q and R which meets at TH at a point T having the coordinate as H and K. Then the path traces by this point of intersection of this tangent at Q and R will be nothing but will be a straight line, and this straight line will be called as the polar of the parabola. So this will be called the polar, and this point fixed point here will given point here will be called as the pole. So that is definition of the polar and pole. Now how to find out the equation of the polar, because polar is nothing but it is a straight line only. So first of all we see that QR here is what? It is a chord whose tangent at Q and R meet at THK. So it represents just like this one. From a point Tx prime y prime you can draw two tangents. We have discussed this in the class. Two tangents to the parabola. Then what will be, then this chord which join the point of contact of these two tangents will give you a chord, and this chord is known as the chord of contact. And the equation of that chord of contact will be given by y prime is equal to twice into x plus x prime. So from this figure here also QR now become the chord of contact drawn from the point T having the coordinate H and K. So in that case the equation of this chord QR here will be given by yk is equal to twice a into x plus h. Let us name this as equation 2, where I mentioned equation 1 as the y square is equal to 4ax, the equation of the parabola. But now you see that Px1, y1 is a point which lies on this chord PQ. Then in this case you'll get y1k is equal to twice a into x1 plus h. You replace x1 by x by x1 and y by y1. So we have this one, but we know that this point THK is not a fixed point, because if the tangent is the tangent at Q and R, then it will give you the position of this point T here. If the point of intersection of the tangent at Q prime and R prime is this one, then it will give you a point T having the coordinates say H prime, K prime. So in that case, this point T, point of intersection of the tangent drawn through the point of through the extremities of a chord which passes through the pole here will not be fixed. So therefore, equation of this polar here will be y1y is equal to twice a into x1 plus x. You replace k and h, k by y and h by x, because k and h here is not a fixed point. It is a moving point, so the path traces by this moving point here will be given by y1y is called twice a into x1 plus x, where y1, x1, y1 is the pole. So this gives you the equation of the polar. Now, next, let us come to this one, which is a corollary of this polar, the definition of that one. It states like this: polar of the focus is the directrix, that is the polar whose pole is the focus, SA0, will be nothing but it is the directrix. Now, from the beginning, we have discussed this one derivation, we have discussed the standard equation of the parabola, where in the standard equation of the parabola, the focus S is given to be, that is a fixed point, is given to be S having the coordinate as A0. And we know that the directrix or the fixed straight line is given by the equation x plus a is equal to 0. This is for the standard equation y square is equal to 4ax. The focus is always given by this one a0, and the directrix is always given by the formula x plus a is equal to 0. Now in this corollary, we have to show that the polar of the focus is the directrix, that is the polar whose pole is the focus. That means if I take this point P x1 y1 as S whose coordinate is a0, then in that case the equation of this line here, or the polar of this one, will be given by this equation x plus a is equal to 0, the directrix. So now how you will get this one? Since we know that from this equation of the polar, y1 y is equal to twice a into x1 plus x, where x1 y1 is the pole here. But if I replace the pole here by the focus S whose coordinate is a0, then in that case you'll see that you put x1 is equal to a and y1 is equal to 0 in the equation. Y1 y is equal to twice a into x1 plus x. We see that y1 has to be replaced by 0 into y is equal to twice a into, what is x1? It is a plus x. So this implies that 0 is equal to twice a into a plus x. But we know that 2 cannot be 0. A also is not equal to 0. So therefore in this case it implies that a plus x is equal to 0. So you see that the equation of the polar now reduces to a plus x is equal to 0. But a plus x always represent the equation of the directrix of the parabola. So from here we conclude that if the pole is given by the focus S whose coordinate is a0, then in that case the equation of the polar will be nothing but will be given by a plus x is equal to 0, the equation of the directrix or the equation of the straight line or the fixed straight line in a parabola. So this proved the corollary.